Good morning, students. Mr. Rops here.
And Miss Weaver.
Right, and we are going to do some linear functions review from last year. And so let's get right to it. We have 2 points A and B, and we want to find the equation line in standard form that contains both A and B. And if you remember from last year, in order to find the equation line, you ultimately always need two things. You need the slope and you need a point. If you have those two things, you are set and ready to go. And the equation that you know that I love is this one, y minus y1 equals mx minus x1. And that equation will get us into standard form. So, starting off, we have to find the slope when we have a and b. Finding the slope, we know slope is y2 minus y1 over x2 minus x1.
So another way to think about that is the rise over the run. Coming back, huh?
It is rise over run.
Something that sounds familiar, hopefully.
Oh yeah. Rise is up and down. That's the y value over the run, left and right, which is the x value. And so if I call this x1 y1 and x2 y2, we just plug our values in. And so it's 1 minus a negative 4. And be careful with that there, please. And I have 1 minus 3.
So I've seen very good math students who aren't careful make a crucial mistake there by not being careful with putting their x1, y1 together and their x2, y2 together.
Right. And I've just made a mistake. I'm a really good math student. Just made a mistake. Let me try that again. I messed up one of my x's and y's.
Y2 is 4. Good thing we labeled them and double checked.
Good thing. Minus the negative 4. That's my y1 divided by x2 1 minus 3. Okay, so good thing we double checked because even the good math students make the mistakes, but you have to catch them. We've got the double negative, so it's 4 plus 4, which is 8. 1 minus 3, which is negative 2, which ends up being negative 4 is my slope. Here is my slope.
So what might that line look like? I just might take a second before we sketch it in here to think about what do you remember from last year? Could you visualize that line already or an aspect of that line already?
Now, I would think it's negative, so it's going to be going in that direction somewhere.
Just like I'm skiing down a mountain.
Exactly, because we always go from left to right when we think about things where you're going that direction down the mountain. All right, so we got our slope. We have a point. We actually have 2 points. Which point would you like to use, Ms. Weaver?
I'm going to go for the easier one. And for me, the easier one looks like point B. 1 is a nice number. 4 is a nice number. Both positive.
Right. Okay. So I'm going to go y minus y1. But hold on a second. We called this y2, and now I'm calling it y1. Is that okay? Back here, we called this y2, but now in this formula it says y1. I've switched it. Is that okay?
Yeah, because it's just general. In general, it's just talking about one of your points.
Right. So this is talking about any point on the line. So then I go negative 4, x minus 1. Do some algebra here. I'm going to distribute the negative 4. X plus 4. And I have to put it in standard form, so I'm going to move this over. So it's 4x plus y. This goes in the other direction, so I add 4 is equal to 8. And this is the equation of the line in standard form. So just to rehash this one, you need a slope and a point. Slope can be found with this formula. And then this particular formula here is the magic formula to get you your equation.
How could we double check our answer?
What you could do, if you want to double check, one method you could do is you could do the whole process again with this point in for y1 and x1 and see if you get the same equation at the end.
Could we also take one of those points or even both of those points and make sure our answer works at the end?
Ah.
So if we took point A and we substituted it into our final equation, can we make sure that that works?
Sure. So this is 3, negative 4.
Let's just make sure if we substitute in an x value of 3 and a y value of negative 4, that in fact does equal 8.
So here's my check. So 4 times 3 plus a negative 4. I hope it equals 8. We'll see. So that's 12 minus 4, which equals 8. Hooray!
There we go. So
Feeling pretty good about that answer now. All right, so good question for A part. A lot of linear function stuff that you did from last year. Now we're moving on to B part. It says find the equation line that is perpendicular to the line through A and B, but through the point 3, negative 2.
Oh, perpendicular.
Oh, yes.
Perpendicular. Some vocabulary.
So perpendicular, if you remember, here's a line, this one's perpendicular, makes a right angle. And if this slope was 2, the perpendicular slope was the negative reciprocal of the slope. They are negative reciprocals of each other. So if I have 3 halves, if I want the negative reciprocal, I change the sign and I flip the fraction. If it was negative 4/7, perpendicular, it would be a positive 7/4. Change the sign, flip the fraction, negative reciprocal. So for our particular question, we have a slope of negative 4 and the point 3, 2. We want perpendicular to negative 4. The perpendicular slope is going to be what, Miss Weaver?
Well, it's not a fraction, so what do I flip?
Well, there is a fraction. It's a 1 hiding there.
Oh, yeah. So it's going to be positive 1/4.
Okay, so here's my slope, 1/4 and 3, negative 2. So slope
We start with what we know.
1/4.
There's our clues.
Point was 3 at negative 2.
It's kind of like a mystery. Here are our clues. The gradient is positive 1/4, and we know that this mystery line goes through the point 3, negative 2. I love mysteries.
And this little equation is a great mystery solver for lines. So we take it, we plug it in. Y minus a negative 2 is equal to 1/4 x minus 3. So y plus 2 is equal to 1/4 x minus 3. And now it doesn't specify what form to put the equation in. I'm going to use standard form because that's the easiest one to get to, especially when I have fractions. So I'm going to multiply both sides of the equation by 4. Because if I do it to one side, I have to do it to the other side. That then cancels the 4 away happily. And I have no more fractions. I have 4y plus 8 is equal to x minus 3, because the 1 times that is just x minus 3. Subtract the x plus 4y equals negative 11. Here is the final equation. If we want to do that quick check, we could take 3, negative 2, plug it in, see if it works. Negative 3 plus 4 times negative 2, negative 3 minus 8 is negative 11. Oh,
It works.
it works.
And we solve the mystery.
And we solve the mystery equation.
Mystery
All right, so there's a lot of linear functions there. Let's try another one in just a moment.